Hey guys, so last week we focused on the triangle congruency theorems and postulates, and we talked about how those are used to prove that triangles are congruent. But this week we're going to focus on really using those, getting all the necessary information, making sure we have all that so that we can say for certain that these two triangles are congruent. So what we're going to do is just go through, use these 5 steps. The first thing you should do is draw it. I know that there's a picture of it on your screen, and that's great, but if you have it drawn down, then that will really help you, because next you're going to mark it and you're going to say, okay, which parts of these are congruent, what can I use, and what can I figure out. That's really the next step, actually, which is decide your course of action. What are you going to do? Um, so you're going to ask yourself, what do I know? What can I find out? And which theorem should I use? And then prove all those necessary things so that you can state what was proven. That's important. Sometimes people will just prove all the necessary things and they say, okay, necessary things proven, but you need to state. If it asks you to say, prove these triangles are congruent, and then you just prove all the things that are necessary, and then you don't say, and therefore these triangles are congruent, you didn't finish. You need to state what you were trying to prove. So let's look at one. So first, draw it. Lucky for me, it's already drawn on there, but you would draw that in your notebook so that you can mark it. So this says, get this out of the way, this says that BC is congruent to DC, and those lines there mean those line segments. So BC is this one. I'm going to mark it congruent to DC, is that one. So now they're marked congruent. AC is congruent to EC, so AC here, and EC here. Sorry, it needs 2 lines, otherwise it's going to say it's congruent to that, but it's not. These two are congruent, and these two are congruent. And then so that's what I know. So now I need a course of action. What do I know? Well, I know these two are congruent, and I know these two are congruent. What can I find out? Well, if I look through here, I should look for things that I recognize. I don't know if this is a midpoint or anything. This is the only thing that's given to me. So the one place my mind goes right now is saying, this here are intersecting, these are intersecting lines. What do I know about intersecting lines? Well, I know that vertical angles are congruent. So that's important, and it looks like right there, then you can say, which theorem should I use? If I have these vertical angles, then those are going to be congruent by side, angle, side. 2 corresponding sides congruent, an angle, and then 2 more sides. So now I need to prove that. I can say, you need to go through, it might seem like a little bit of work, but you need to go through and say, BC is congruent to DC, AC is congruent to EC, and those are given. Those are given. And then I can say angle BCA is congruent to angle DCB because they are vertical. So I have side, angle, side, and I can state what was proven. Triangle BCA is congruent to triangle DCE. Remember to make sure that these are going in the right direction. So I did BCA and DCE. Those are the ones that are congruent. By side, angle, side, and you're done. So here you can see I needed to state this, even though this was already said. I need to state this, that's given, and I need to state this and say why. I know that these are congruent because of this. Now that I have that necessary information, I can say this, which is what it was trying to prove. Okay, let's look at another one. This says, okay, so of course I'll draw it. It's already there. Mark it. So angle G is congruent to angle I. Angle G congruent to angle I. Marking it. FH bisects angle GFI. Now, what does bisects mean? Bisects means, well, when you see bi, that means two, right? It's going to split it into two equal parts. So I'm going to have two equal angles here then. So because this is bisected, this angle here and this angle here are going to be congruent. So I can mark that. That is given. So now I have to ask myself, what do I know? Well, I know I have an angle here, an angle here, angle here, angle here. What can I find out? Well, if you look at this, I can find out that angle GHF is going to be congruent to angle IHF, because if these two angles are congruent, the third one has to be, because they add up to 180, right? I've got this one, which is the same as this one and this one, so these two have to be the same as well. But I can't use angle, angle, angle to say it's congruent, right? That is a similarity. Angle, angle, angle is for similar triangles, because this could be any size. The angles can be the same, but they could be different size. So I need to prove something else. What can I prove? Well, I know this is congruent to itself. Of course, it is itself. So I can say, well, which theorem should I use? I've got an angle, and a side. So angle, angle. Side theorem would be good, right? Perfect. So let's prove the necessary things. So let's go through and say angle G congruent to angle I is given. And then I can say angle GFH congruent to angle IFH. And that is because FH bisects GFI. And since this bisects this angle, these two are congruent. That's why I can say that. And then I can say FH is congruent to itself. Anything congruent to itself, that's the reflexive property. Reflexive, congruent to itself. Of course it's congruent to itself. You would say that, but you have to state that. It's a reflexive property that says something is congruent to itself. So then I can say triangle GFH is congruent to triangle IFH by AAS. Again, I needed to go through and find all the necessary stuff. These angles are congruent because it says so. These angles are congruent because this bisects here. So that cuts it in half. And this is congruent to itself. So I have angle, angle, side, angle, angle, side. That's why it's congruent. You need to state all those things, make sure everything that you need for whichever theorem that you pick is stated, and there's a reason